Yeah, comes on everyone. Let's start off. Hope everyone has gone through the notes. Last class, we started with the two block problems. Great. Let's go ahead with that. So we got two blocks here. The floor is smooth. And let's say this mu is 0.3. And you're applying F is equal to T. So force is changing with time. So as time passes, the force will keep increasing. Let's make it 0.2. So at T is equal to 0, force is 0, T is equal to 10, force is 10, and so on. So plot acceleration of the blocks versus time. So how does the acceleration of block 3 kg and 2 kg change with time? Okay. So last time we saw if I apply this much force, what was the acceleration and all, but this is even better. So as time increases, all possibilities and all cases will get covered. Others, you need to keep your cams on. Take a minute or so, and I'll show you one. How do we proceed with this? Let me show you one. See, so how do you handle these kind of questions? Whenever you see two blocks and there's a friction between them, you always start with an assumption. Let the blocks go together. That is the thing. Don't put F maximum directly. There is no guarantee they will slip. Assume blocks go together.
कुछ नहीं हुआ.
And we have an acceleration A here. We have F is equal to Fa, and we get acceleration is equal to T by 5. So if they go together, they'll go with this acceleration, whose acceleration is changing with time. So at T is equal to 5 seconds, acceleration is 1, T is equal to 20, acceleration is 4, and so on. Next thing, you have to check for the friction ka value. So take any one block. I'll take the 2 kg block. So on the 2 kg block, there's a friction will act forward and the acceleration is this way. F is equal to 2a, but a is 2t by 5. But we know the friction ka value is always less than equal to F max, which is mu into n. So in this scenario, 2t by 5 is less than equal to 0.2. N is the normal reaction between 2 kg and this guy, which is 20 newtons. So we will get T is less than equal to, how much is that? 4 to 10 seconds. Now let's try to understand the meaning of this. What is the meaning of this? So this is saying 2t by 5, 10 or 10 seconds, no? 10 seconds only. Now, what is the meaning of this? The friction is telling you, see, friction is telling you, this is how much friction I require. This is your required friction. So at t is equal to 1 second, friction requires 2 by 5. At t is equal to 2 seconds, friction requires 4 by 5. At t is equal to 5 seconds, friction requires 2 seconds. So friction ka requirement is also increasing with time. So, but friction maximum, it can give only 4 newtons. So at 10 seconds, friction will reach its maximum value. So this is the meaning of this. So up to this time, so up to t is equal to 10 seconds, they will go together. That's my assumption. And that is right, because up to 10 seconds, friction can provide whatever you're asking. So this is how you do. Whenever they ask us function of time t, you will get a limit. So then great. So what happens after 10 seconds then? So that means for t greater than 10 seconds, blocks slip. That is also fine. If the blocks are slipping, that is also great. That means friction is maximum. I hope you're getting the problem. If they're not slipping, I get the answer. If they're slipping, then I know the value of friction. Then draw the FBD of both the blocks separately. 2 kg, and this is F max, which is equal to 4. This is 3 kg, F max will be backward. 4, and this is F is equal to T. Let this be acceleration A1, let this be acceleration A2. So we have A1 is equal to 4 by 2, which is 2 meter per second square. So after 10 seconds, the upper block will go with a constant acceleration, assuming it won't fall down and all. So, and this will, A2 will be T minus 4 is equal to 3A2. So we get A2 is equal to T by 3 minus 4 by 3. So look at the accelerations. So this is the answer for t less than 10. This is the answer for t greater than 10. Now you want a graph. You can see them, all are straight lines. So if you try to plot a graph, A versus time graph. So up to 10 seconds, both of them will go together. What is the acceleration? A is equal to t by 5. So if you take this angle as theta 1, A is equal to t by 5 for t less than 10. So tan theta 1 will be the slope, which is 1 by 5. After that, it becomes constant. 2 meter per second square. This is the acceleration of 2 kg block. The other one also will be the same line. After 10 seconds, the graph will become like this. This angle is theta 2. Look at the acceleration, t by 3 minus 4 by 3. That means, look at the slope here. Here the slope is 1 by 5. Here the slope is 1 by 3. It becomes more steep. Tan theta 2 is 1 by 3. So the graph will actually diverge, and this will be the acceleration of 3 kg block. This will keep increasing forever. It's a straight line. Is the graph clear, everyone?
Sir, what do the the horizontal line and that the theta 2 wala slope indicate here?
What do they indicate? They are the accelerations. They are the accelerations. This is an AT graph.
Yes, sir.
So I'm just drawing the equation of this curve and the equation of this curve. Y is equal to mx plus. It is a straight line equation. What do they indicate? They indicate acceleration versus time graph. What do you want to ask exactly? Think about what you want to ask and ask me. But others, is this clear? Be clear with your doubt. Na? If I don't understand what you're asking, how will I answer you? Aditi,
How did you get S max?
how did I get F max? Mu into n.
But wait.
Mu is 0.2 and n is 20.
Sir. No, okay.
No?
All right. Yeah, got it. That was.
Did
Sir,
you figure out what you want to ask?
I did not exactly understand why did you draw that, straight line and that, that theta 2 wala.
Because acceleration became constant here, 2 meter per second square. It's a number.
Yes, sir, that, and then the theta 2.
That is this one, t by 3 minus 4 by 3. It is the equation of a line which is depending on time. Yeah, you can stay back after the class. We can discuss.
Okay, sir, okay.
How did you get tan theta 1 by 3? Looks like you guys are confused with the straight line equations. Y is equal to mx plus c. Listen, Advait, it's the same thing. So a2 is equal to 1 by 3 into t minus 4 by 3. Can you see that? It looks like a straight line equation.
Yes, sir.
So what is a straight line? It's a line not passing through the origin. That's why the line looks like this.
Oh.
Vanshika, clear with that? So slope here is 1 by 3. Be clear, na? If you didn't understand why that the graph is drawn, you should say that. Let's see the same thing. I'll just change few numbers here. Two kg block, 3 kg block. Let's say this is F is equal to T. Let's say here mu s is 0.2, mu k is 0.1, and let's keep the floor smooth. Now can you draw the graph? Ground is also rough. Let's get these two. Now, this is the first time you're seeing mu k. What is mu k? If the bodies slip, the friction becomes mu k into n. If the bodies don't slip, then the friction is mu s into n. So that is the only difference with mu s and mu k. Oh, let's do one thing. Wait, let's keep this way, both mu s, mu s. We'll do it as 4 cases. They should make things clear. All surfaces are rough and all surfaces has mu s, mu k. Let's do the B part. Let's go one step at a time. Then you'll understand how things will change for each term that you're adding up. Generally, 2 blocks, these are all the possible cases. Now you can keep the force on the upper block also, but yeah, the game is still the same. Same story, meaning you just keep doing the same steps. How do we start? Assume both the blocks go together. Let the acceleration be a. So we get a is equal to t by 5. Till here the story is same. Then choose any one block. I will choose the 2 kg block. The one who is moving it is the friction between them. So we get F is equal to 2t by 5, 2a, which is 2t by 5. This must be less than equal to F max, which was 10. Remember here F max is mu s into n. If it is not slipping, then the friction is mu s into n. 0.2 into 20, no, sorry, 4. Mu s into n is 4. Then we get t less than 10 seconds. So till here, if you see, the story is the same. Nothing changed. Then for t greater than 10, the blocks slip. And now mu k will come into the picture. And therefore, friction will become Fk, which is mu k into n. So the friction ka value will change, which is 0.1 into 20. 2 Newton. So if it is slipping, then you can just draw the FBD separately. 2 kg. This time don't put Fs max, we'll put Fk, which is 2 Newtons, and this acceleration is A1. Force is 2, mass is 2 kg, so this is 1 meter per second square. So the 3 kg, this will be Fk. That's it. That is the only difference. The starting part will remain same. Once the block starts slipping, friction will not be any more 4. It will become 2 suddenly. It drops. So this will be t minus 2 is equal to 3a2. We get a2 will be t by 3 minus 2 by 3. So see, before 10 seconds, this was the graph. A is equal to t by 5, line passing through the origin. After 10 seconds, a1 becomes constant and a2 becomes y is equal to mx plus c. Now, if you try to plot a graph for this, so initially for 10 seconds, it's a line passing through the origin. How do I know that? This thing looks like y is equal to mx. M is 1 by 5. This is theta 1. Tan theta 1 is 1 by 5. This goes till 10 seconds. Now see, something happens. At 10 seconds, technically, this value must have been 2. But what happened to the after less than 10 seconds, the graph will suddenly drop. And the graph starts from here. It becomes a discontinuous graph. This will be the acceleration of 2 kg block. And look at this value here. A2, if you keep t is equal to 10 here, you'll get 10 minus 2. This actually becomes, at t is equal to 10, A2 is 8 by 3, which is 2.66. That means the 3 kg block graph will be like this. And then suddenly it jumps up. Then it becomes like this. This is theta 2, where tan theta 2 is 1 by 3. This is the acceleration of 3 kg block. That is how the graph looks, everyone. It will be discontinuous. So after 10 seconds, the graph values will suddenly get messed up because the friction went from suddenly 4 to 2. So the 2 kg block will start going with a lesser acceleration because the reason the 2 kg is moving because of friction. Initially, friction was pushing with 4. Now suddenly it pushes with 2. So the acceleration suddenly drops. If mu k data was not given, then we take mu s is equal to mu k. Now here also see, I just gave mu s, right? Mu k is not given. That means you take mu s is equal to mu k. I'll do one thing. If that's confusing, I'll just write it as mu. You can put on the data point. So now try the third one. Idea is the same, but this time there's a friction on the ground also. So this is 0.2, 0.2. Others who want to go for the third part, you can go ahead. But others, please have a look at this page. We followed the same process. Step 1, assume both the blocks go together. Acceleration will be t by 5. Then we found the f required, which is 10 seconds. Till here, the story was same as the previous problem. The story changes after 10 seconds. Now, because there is a mu k, the friction after slipping will be mu k into n. In case you forgot, in the graph, if you remember, there was a drop AB. We have ignored this till now. Friction actually drops for decreases and then becomes constant. So in our case, the friction has gone from 4 newtons maximum to 2 newtons. Now, because the friction suddenly changes, the acceleration will suddenly change. That is the reason the graph becomes a gap. You have a hole in the graph there. It's a discontinuous function. Any doubts on the graph? How did I draw the graph? Why it is looking like that? If you can see there, this is looking like y is equal to mx plus c. Y ka place mein a is there, x ka place mein t is there. What are you asking, Rishi?
Sir,
It's undefined. It is undefined. That's why there is a thing. So at 10 seconds, it is still static only. Slipping has not started yet. 10.00 something, it will be static, kinetic.
okay, sir.
Can you do the C part now? Get the graph. Now 3 kg. What is the FBD of the 3 kg? See now.
Sir, वो graph वाला part.
Graph wala part. Look at this thing. Till 10 seconds, the graph was t by 5. Line passing through the origin. Agreed? At t is equal to 10 second, what is the acceleration? 2 meter per second square. So this value was 2. But if I keep t is equal to 10 in this guy, see if I put t is equal to 10 in this, what will I get? A2 ka value? I get 8 by 3, which is 2.66. That means this graph will suddenly jump to 2.66 and then we'll start from there now. The graph won't start from 2 seconds, 2 axle 2, it will start from 2.66. So that's the reason you got a discontinuity there. Let's get C and D. So out of all, D is the worst one. How will you handle C? Try. You got a minute or two. Let's see the third one. You can keep trying. 3 kg, this is F is equal to T. This is 0.2 and 0.2. Now this is different from the previous problem a bit. Tell me one thing, when T is equal to 0, force is 0. At T is equal to 1 Newton, first of all, let's look at the friction on the ground. What is the maximum friction between the ground and the 3 kg block? That will be mu into n ground, which is 0.2 and the normal reaction is 50, meaning this is 10 newtons. Now think from the perspective of 3 kg block. That means if you want to move the 3 kg block, first of all, you need to break the friction on the ground, isn't it? Until and unless you apply at least 10 newtons, the blocks won't even start moving. Is that making sense? So for the first 10 seconds, for t less than 10 seconds, blocks won't move only. because the force F is less than F maximum, F ground maximum, which was 10 newtons. At exactly 10 seconds, you're applying force and the friction on the ground will become maximum, right? Then the graph will start from here. So for t greater than 10 seconds, the blocks will start moving. Then if they start moving, how do you start? Assume both the blocks go together. The story is still the same. Yeah, that looks right. Now from here, it will be the same standard process. Assume blocks move together. So the thing is this, in this question, right, think about how many different scenarios are there. Scenario 1, nothing is moving. Scenario 2, both are going together. Scenario 3, both are slipping and going. These are the three possibilities, isn't it? So assume both are going together. Then how do we do that? If both are going together, draw the FBD. 3 kg, 2 kg. This is equal to F is equal to T. Now remember, if you are moving, that means friction on the ground is maximum, or else you won't move in the first place. And this is 10 newtons. And acceleration. So we have T minus 10 is equal to 5a. So acceleration will be T by 5 minus 2. This is the acceleration of the blocks after 10 seconds. But this will go until when? Choose any one block. I'll take the 2 kg block. The reason this is moving is because of the friction between them. And acceleration is a. F is equal to 2a. But a is 2 into T by 5 minus 2. This is a normal reaction and this is your 20. And we know friction must be less than equal to mu into n. Now remember, this mu and n is between 2 kg and 3 kg block. This will be 2T by 5 minus 4 is less than equal to 0.2 into this is 4 newtons. So that will be 8 into T is less than equal to 20 seconds. Meaning up to 20 seconds, both the blocks go together. That is the meaning of this. Friction is saying, boss, up to 20 seconds, I can give whatever value you want. This is the friction between the blocks. The ground ka friction, I'm using Fg ka symbol. I'm going to call it Fg maximum. So up to 20 seconds, both the blocks are going together. That is how you started the assumption. And this is the required friction. Friction is saying, give me this value, I'll make sure they go together. And you can give this value up to the value reaches 4 newtons, and this will happen at 20 seconds. Any doubts on this page? Then the next part, after 20 seconds, what happens? After 20 seconds, both the blocks will slip. Are you getting how we're doing these problems? Step at a time, each scenario you are analyzing. So if they ask you as function of time, that actually covers everything. So for t greater than 20 seconds, blocks slip. If blocks slip, therefore frictions are maximum. So all frictions must be maximum. Then it is fine. I'm happy about it. If the friction is maximum, my job is done. This friction will be F max, which is 4 newtons. This is your acceleration A1, so this comes out to be a constant value, 2 meters per second square. And if you take the 3 kg block, this is F is equal to T. And don't forget, there is one more friction on the ground, Fg max, which is 10. And this is also F max, which is backward. This is also 4. This is your A2. So T minus 10 minus 4 is equal to 3A. So acceleration will be T by 3 minus 14 by 3. So if you try to plot the graph, now the graph has actually 3 parts. First, for 10 seconds, no one moves. So the graph will be a line passing through this thing. And then the graph increases till 20 seconds. Then the graph becomes constant. This is a 2 kg blocker scenario. If you look at the 3 kg block scenario, even 3 kg block won't move for 10 seconds, the green line. Then it will go together with the 2 kg block for another 10 seconds, 20 seconds. Then the graph will split. This, if you just look at this part of the graph, this looks like the first part of the question, isn't it? This looks like part A with a 10-second delay. Look at this graph and look at this graph. So it looks like exactly the same graph, but there's an extra 10 seconds delay here. The whole question looks the same. And yeah, so tan theta 2 will be 1/3. How did I get that? This is the slope. This tan theta 1 is 1/5, same story. Are you clear, people, what to do if there is a friction on the ground? If there is a friction on the ground, there is a possibility blocks won't move for some time. We have to calculate that first. So there are 3 possibilities now. They will not move, they'll go together, they will slip. Clear with this? Any doubts on how we did this, step by step? Any confusion, anything you're not convinced? Now can you do the D part? Mu S, mu K ground and the between the blocks. There, if you see, I'm just adding one after another. I think if you can get this, I think two blocks you can handle most of the models. Right, I'll give a minute more. That kind of looks right, Andrea. Let's see. Now, first of all, before even starting, let's try to get a story like what is happening here. Do you think the blocks will start moving immediately? No, right? Because there's a friction on the ground. Unless you break this friction, the blocks won't move. So first you need to exceed that friction. So that friction will first slip. The ground will slip first. But the moment it slips, friction will change. Then 2 and 3 will go together for some time. Then 2 and 3 will slip. So friction will again change again. So Every time it slips, the F value will keep getting messed up. So let's do it step by step. So what is friction on the ground? Remember, this will be static. That will be 0.2 into 50, 10 newtons, the same thing what we got before. That means up to 10 seconds, no one is going to move. Now for t greater than 10 seconds, the 3 kg slips on the ground. Therefore, friction becomes F is kinetic. That means the friction is not 10 anymore. So I'll write it as Fk, ground G will be mu k into n ground. That becomes 0.1 into 50, which is 5 newtons. So assume both the blocks go together. After the 3 kg slips, both the blocks will go together for some time. Two kg, 3 kg, this is F is equal to T, and this friction will be Fk ground, which is 5. This is the acceleration. So we get T minus 5 is equal to 5a. So we get acceleration is equal to T by 5 minus 1. Choose any one block. I'll choose the 2 kg block. So this is the friction between them. Acceleration. So this will be F is equal to 2a. But we know this friction must be less than equal to mu s into n. Remember, this n is 20 newtons. This is the F between them. So this will be 2 into T by 5 minus 1. This will be 0.2 into 20. That's 4. That will be 2, 3. So T less than 15 seconds. So up to 15 seconds, they'll go together. So at 10 seconds, they'll start moving, and up to 15 seconds, they'll go together, and after 15, they'll slip. Is the story clear till here, everyone? You just have to be careful with the diagrams and the equations, one after another. Clear with this? Then what? Then after 15 seconds, for t greater than 15 seconds, blocks will slip. Because your assumption they'll go together is only till 15 seconds. Means after 15, then they can't go together. Block slip. Therefore, friction between them also becomes kinetic. So 2 kg block, this friction becomes kinetic Fk, which is mu k into n, which is 0.1 into 20, which is 2 newtons. This is the acceleration a1. So we get a1 is equal to 1 meter per second square. And if you take the 3 kg block, F is equal to T This friction has become Fk, which is 2 newtons. This friction will be Fk ground, which is 5 newtons. This was the acceleration A2. So T minus 7 is equal to 3A2. A2 will be T by 3 minus 7. One thing, if you observe, the slopes will remain same. The values are changing. So this is how the graph looks, everyone. So one thing, if you notice, right, if something like this comes in the exam, it is kind of little easy to guess from the options. Every time there's a kinetic friction, there'll be discontinuity in the graph. So observe this. In this question, there is one kinetic friction. There is one discontinuity in the graph. So here we have two kinetic frictions. So there'll be two discontinuities in the graph. So there should be two holes in the graph. So you can eliminate at least two options. Let's see how it is that. So for 10 seconds, no one is moving. So for 10 seconds, no one moves. And then suddenly at 10 seconds, what happened? Look at this thing. If I keep t is equal to 10 here, we get a is equal to 10 by 5, 1 meter per second square. It is not zero. The graph is discontinuous. Suddenly the value jumps and then it increases. The value will suddenly jump to a is equal to 1 meter per second square. Look at this. It is not moving. And suddenly, if you put t is equal to 10 here, you're not getting 0 there. If you had got 0 there, the graph would have been a continuous graph. It would have been connected to the ground, that horizontal line. And this will go until when? This will go until 15 seconds. And what value will you reach? If I keep t is equal to 15, that will be 15 by 5, 3 is equal to 1. So you'll reach a value of 2 meter per second square. Again, I'm doing nothing, no physics here. It is just max. I know the equation of this line. I'm just trying to figure out how to draw this. So the value will reach 2. At 15 seconds, this will slip, and then the value becomes 1. So the graph will suddenly drop and become like this. This is the acceleration of 2 kg block. It remains 0, then it bumps up, it then falls down again at 15 and then becomes constant. How does the 3 kg look like? Initially 3 kg also will not move, so the story will be same till 15. And this also will jump. And then look at this thing here. If you put t is equal to 15 here, we get a2 is equal to 15 minus 7, 8 by 3. That's again 2.66 something. So this value will jump here. And then the graph will go like this. This value is 2.66. So there, that is one more discontinuity. This is the acceleration of the 3 kg block. So every time there is a slipping, the graph will get disconnected. Do have a look at this. Clear what we did? So first you assume they'll not move, see then they will move, and after moving they'll go together for some time, then they will slip. Any doubts on this? Clear? Can I go ahead? Let's see one more. There, I kept all the 2 block cases in one place. So this is how you can play with μk. So that is the catch with μk there. Let's see another variation of this. Let's say you're applying f is equal to t on the top. I'll keep the numbers same, 2 kg block, 3 kg block. Let's say this is 0.1. Same thing, plot 80 graphs. Here also I can keep mu s and mu k. That becomes more deadly. But let's get this. Just give it a try. Let's see. Hmm. Okay, let's see. So in this, right, there's a small trap, especially the second part. So whenever you see a problem like this, two blocks, but when you're applying force on the upper block, you need to always check something. Tell me one thing, who is responsible for moving the 3 kg block? The friction between 2 kg and 3 kg, isn't it?
Yes, sir.
So just look at the scenario here. In this scenario, 2 kg. This was F is equal to T. Let's call this thing F1. So whenever you get this thing, you always have to check once. This is F1 and this is F2. What is F1 max? Your F1 max is 0.5 into 2, 10 newtons. F2 max is 0.1 into 5 newtons. So this is fine. So 3 kg can move. So then you can go ahead with your regular stuff. Assume both are going together, blah, 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 all that thing. 3 kg can move. But look at the second scenario. If I do the same thing here, in this case, F1 max will be 0.2 into 2, 4 newtons. Whereas F2 max will be 0.2 into 6, 0.2 into 5, 10 newtons. Means what? No matter how much F1 tries its best, it can never break 3 kg block, isn't it? Is that making sense? Since F2 max is greater than F1 max, 2 kg will never move. 3 kg will never move. So the second problem actually is easy. You can just treat this, like 3 kg as a ground and just solve for 2 kg. Is that making sense? So if you apply force on an upper block, you need to check whether the ground block can move or not in the first place. There, that is one. Now let's try to do this. Same story. Assume both the blocks go together. But before that, we need to break the friction on the ground. What is F max on the ground? F ground maximum is 0.1 into 50, 5 newtons. Means for t less than 5 seconds, no one moves. It's the same thing what we did before. For t greater than 5, 3 kg slips. Therefore, F ground max will be 5 newtons. Then assume both go together. Then we have t minus 5 is equal to 5a. Then take any one block. I can take the 2 kg block. This is F is equal to T. This is the friction and this is the acceleration. So T minus F is equal to 2a. Acceleration is T minus 5 by 1. T minus F, this will be 2 into T by 5 minus 1. So F will be 3T by 5. Plus 2. And this should be less than equal to 0.5 into 20. How much is that? That is 10 to 8. We are getting 8, 8, 5, 40 by 3 seconds. Check. Did I mess up some calculations? You could have taken 3 kg block also. That would have been easy, but okay. T minus F is 2 into A, and A is T by 5 minus 1. This is T minus F. This is 2T by 5 minus 2. The F is there. That looks right. Clear with this? So up to 40 by 3 seconds. I think that's around 16.66 or something. They will 16 or 13.33. They will go together. After 40 by 3, they will slip. And by now you got the process. Just straightforward, it is boring. Just keep solving one after another. To k greater than 40, all surfaces slip. Now imagine if I kept mu k also here, it would have been more messed. But you know how to handle that also. That means that friction has become maximum. So 2 kg, this will be F is equal to T. This friction has become maximum, which is 0.5 into 20, that's 10. Acceleration T minus 10 is equal to 2A. Acceleration is T by 2 minus 5. 3 kg block, this is 10. F ground max is 5. A2 will be 5 by 3. There. Now, if you plot the graph, for 5 seconds, no one moves. Then till 40 by 3, you increase. And after that, you still increase. The graph actually becomes more steep. Because here the slope was 1 by 5 and here it is 1 by 2. I hope everyone is getting how am I getting the slopes. Y is equal to mx plus c here. M ka place mein 1 by 5 is there. Here M ka place mein 1 by 2 is there. For the 3 kg, it will be the same till 40 by 3. Then it becomes constant. Is this clear, everyone? Getting it, this is how you handle 2 block problems. And don't start with, F is maximum. If you start solving, you will go up. And for the second part, it is straightforward. So So 3 kg block never moves. So technically there's nothing to do. You can just take the 2 kg FBD and solve the problem regularly. This is F is equal to T. This is F. F max will be 4 newtons. So for T less than 4, 2 kg will be at rest. It is just a 1 block problem. And for T greater than 4, and this friction has become 4. A is equal to T minus 4 by 2. So if you try to plot this graph, so for 4 seconds you don't move. After 4 seconds you'll increase. If you look at the 3 kg block, it never moves. It is always on the ground. Play with this. Clear? Take a break. Come back by 9:43. Any doubt so far? So that's how you get to blocks. Next thing, we will see 3 blocks. 3 blocks are not there in the portion, but we will see 1 or 2 just in case. Mains mein to they'll never ask. Advanced mein there is a possibility. Any doubt so far?
The 3 blocks are not there in the portion.
Hmm.
Okay, sir.
There's a lot of things which are not there in the portion. We always do, but. Chalo, take a break. Come back in 5 minutes. Comes on you. Let's see the next one. Same thing, plot AT graphs. This time you have 3 blocks. Try, think for 2 minutes, then I'll show you how to handle this. This will be a little different than the 2 blocks. Why there will be no movement? Ground is smooth record. Even if you apply 0.1 Newton, all the system will move. There is no one to stop you from. If you take the whole thing as one system, who is stopping the system from moving? Ground is smooth. All the frictions are internal. So in this case, there are only 3 possibilities. All are going. There is no case where the system will be at rest. Yeah, if you put T0 though. All are going together, then maybe any one block is slipping, then 2 blocks are slipping. If you had kept friction on the ground, then that also would have been a possibility. Let me show you one model and then I'll give you one more like this. So listen how to do this thing. Everything is same. There'll be one change though. We'll start with the same assumption. Assume all are going together. This is something I keep telling you. Keep the process simple, right? Don't run behind, learning 3, 4 different variety models. You're not here to do research, right? We are not doing any PhD analysis here. We are just planning to go and crack an exam, right? I don't want you to go to the exam and start thinking like, when there is a question, should I do this method, this method, this method, this method, and you start getting confused and your time runs out. Choose any one method which you're comfortable. Let it take 1 minute more. It is fine, but you be clear and confident. Think about it. Final exam, right? 2 years ka portion, 3 subjects, you have 3 hours. You'll be under a lot of pressure. We don't want to put more stress on your brain. So keep it simple. So assume all go together. This is what I'm saying. You see 2 blocks and friction. Start with this, assume all go together. And then let the acceleration be A. And then we have F is equal to total mass is 10A. So we got acceleration is equal to T by 10. Great. Then let's choose the 2 kg block. The reason 2 kg block is moving because of this friction F1. And this is A. So F1 is equal to 2A, which is T by 5. But we know F1 ka value is less than equal to, this is N1, this is 20, and that mu is 0.1. So that's 0.1 into 20, which is 2 newtons. So we will get T less than 10 seconds. Understand the meaning of this. F1 is telling you up to 10 seconds, I can make sure 2 kg and 3 kg will go together. That's what it is telling. Up to 10 seconds, 2 kg and 3 kg can go together. They don't talk about 3 and 5. So this is the thing with the frictions. Every friction will think only about its own surfaces. It doesn't care about the other guy. Now, if you take the 3 kg block, then this friction will be F2. This will be acceleration. This F2 will be 3A, which is 3T by 10. This must be less than equal to 0.2 into normal reaction will be 50. That would be 10, and T will be less than equal to 100 by 3. This thing, this N2 is 50. 0.2 into 5 is 10, 100 by 3. So what is this thing saying? This thing is saying up to 100 by J, that is 33.33 seconds, I can keep them together, but there is a problem. Right? This is saying up to 100 by 3, it can go together. The problem was up to T is equal to 100 by 3, 3 kg and 5 kg go together. So when this happens, right, then you have to choose the minimum of these two. So we got this and we got this, right? Now see what happened here. You got this value under what the assumption? Under the assumption all will go together. But what happened at 10 seconds? 10 seconds, 2 kg and 3 kg slipped, right? So the assumption is not valid anymore. Are you getting it? So this is wrong. You don't take this thing. So choose the minimum value between them. Because this 33.33 seconds was derived under the assumption 2 and 3 kg are going together. But we know at 10 seconds only 2 and 3 kg started slipping. So you take the minimum time. Choose the minimum condition. And ignore the other. So basically this 100 by 3 is wrong. So we will ignore this. Are you clear? This is the problem. You need to check for both of them. You don't have an option. So the question is like this. For 10 seconds, all go together. After 10 seconds, 2 and 3 kg will slip first. Is that making sense, everyone? How did you get 10 to 50? This total weight, Nare, Vanshika, 3 plus 2, 5 kg. That normal reaction is 50, right? Between 3 and 5 kg. Any other doubts on this? So this is the headache with the 3 kg problem. You need to check which block will slip first. Let's see, actually, when will the 3 kg and 5 kg slips? So for t greater than 10 seconds, 2 kg slips. Okay, then draw the FBD of the 2 kg block. This will be F1 max, which will be 0.1 into 2, that's 4 newtons. This will be the acceleration of 2 kg. So acceleration of 2 kg will be 4 by 2, 2 meter per second square. This has become constant. Now the other two blocks, the 3 kg and the 5 kg. We have force F is equal to T. Don't forget, we have a friction here also, F1 max, which is equal to 4.
So can you show the question again?
Then what did you send, right, without the question?
Sir, no, I think I took 0.1 as the FS max. Yes, sir, it's 0.1 right, for the 2 kg block. So I guess it's 4 Newton.
ठीक है. Here there is no problem, no? यहाँ पे 2 Newton था. सही है. Good thing. You saved us. Then, now what? Now there's the 2 blocks and there's the force. What to do? Assume both are going together. Again, you start the story. Now it has become a 2 block problem. You made 3 block into 2 block. Assume 3 kg and 5 kg go together, and let's see when these two things will slip. Let this be acceleration. So we get T minus 2 is equal to 8a. Choose any one block. I'll choose the 5 kg block. This must be less than equal to, this section was 0.2. And that normal reaction was 50. How much was that? 10, that will become 2. T by 8 minus 1 by 4 is less than 2. That will be T by 8 is less than 9 by 4. 4s are 2s are 18 seconds. There, did you see what happened? That this is the reason this is wrong. This is 33.33. But actually the block started slipping at 18 seconds. Because this 100 by 3 was derived under the assumption 2 and 3 kg were going together. The moment 2 and 3 started slipping, this F1 ka value has become constant. So now all the load is falling on F2 only. So F2 has to provide more and more friction. There's no one to help you out. F2 is alone. So the slipping will happen even much before 33.33. The slipping started at 18 seconds only. Clear with this? I know, little calculations line. It is just all put the assumptions all, put the assumptions all. It's a brute force. Then for t greater than 18 seconds, everyone slips. Then you're done. So 3 kg, F is equal to T. This F1 max was 2. This F2 max was 10. So acceleration of 3 kg will be T minus 12 by 3. The 5 kg will be F2 max. This is 10. Acceleration of 5 kg will be 2 meter per second square. There, if you try to plot the graph, what was the acceleration initially? Initially, the acceleration was T by 10. Then the acceleration is, this became constant 1. This was T by 8 minus 1 by 4. Then T by 12 minus 3. So for the first 10 seconds, all will go together. This become constant. This is a 2 kg block. Then it increased. This became constant. This is a 5 kg block. This is your 3 kg block. So there'll be 2 times the graph curve will change. This is theta 1, this is theta 2, this is theta 3. Tan theta 1 is 1 by 10. How did I get this? From here, slope y is equal to mx. M is 1 by 10. Here the slope is 1 by 8. Here the slope is 1 by 3. So tan theta 2 is 1 by 8 and tan theta 3 is 1 by 3, and this thing will occur at 18 seconds. Check. Is the graph clear, everyone? So at the point when the slipping starts, the slope will keep changing. It will go faster and faster because there's no one to stop you. Previously, the friction was increasing, proportional to your force. But once the friction becomes constant, there's no one to increase. And this is the reason why you should discard the bigger value. So always discard the bigger value and take the smaller one. Because both the values were derived under the assumption the other guy was not slipping. So whoever slips first, that guy is right and the other guy will go wrong. Why did F2 point and if not 30? Gods, what is the normal reaction between 3 and 5 kg?
सर बट 2 तो ऑलरेडी स्लिप हो चुका है.
स्लिप मतलब गिरा नहीं है ना, ऊपर है अभी भी. So you mean to say this will slip ऐसा? ये ना ऊपर से n.
अच्छा ठीक है.
Slip मतलब it is sliding. It doesn't mean it fell off and went off and it is jumping somewhere. It is there on top of it. मतलब block ऐसा हो जाएगा. Normally we don't take that case of, maybe the 2 kg has gone little to the side. It is still on top of it. I know, you guys assume like that. Basically, these blocks are so big now, they will never fall off each other. All clear with this?
So if they are about to fall, they mention the
Then they have to give the lengths and all ना. यही already complex, इतना calculations कर रहे हैं. अभी ऊपर it will jump and fall and fly. छोड़ना. People are already exhausted with the 3 block problems. Is this clear, everyone? Let's do the same thing. You guys try this. Let's do one more so that you guys get used to it. I'll keep all the numbers same. But this time the force is at the bottom. Now you guys plot AT graph. I think if you can do this, you understood how to do 2 blocks. There, I showed you one, now you do. Tan theta part, Siddesh, it is just slope, right? Y is equal to mx plus c. M is the slope. So here, what is the slope of this line? 1 by 3. So tan theta is 1 by 3. Slope of a line is tan theta. Theta is the angle made with the horizontal. Let's get this. Try. Everyone should try. It's okay to get a wrong answer, but try. Don't get tired now. I did all the work. I should be tired. You guys were just listening to it as it's like a movie only. Now try. Same story. Assume both are going together. Find the value of F1, find the value of F2, both the friction. See when they slip. Whoever is smaller, take that guy, ignore the other one. Then the other two blocks will go together and then start the problem again. So 3 block becomes 2 block and then 2 block again you solve. Let's see the starting part. Let's see whether you got that right. You can check where it went wrong. If you got it, then keep going ahead. Assume all go together. The thing is, I'll always have one standard process, because if the problem changes, at least you'll know what to change in the process. Every problem, if you think like, I will do something new and all, you will have a problem. Matlab, you won't get speed. Have a plan, then you'll at least know the plan is messed up. If you don't have a plan, then everything is right. So acceleration is t by 10. The story is still the same here. Then take the 2 kg block. The only one who's pushing you forward is F1. This is the acceleration. So F1 is equal to 2a, which is t by 5. And I know this must be less than equal to 0.1 into 20. So I got the same thing here. T is 10 seconds. So this guy is going to slip at 10 seconds. Then let's take the 5 kg block, or let's take the 3 kg block. Let's take the 5 kg. This is F is equal to T, and this is F2, and this is acceleration. So T minus F2 is equal to 5a. 5a is nothing but T by 2. So we got F2 is equal to T by 2, which is less than equal to this normal reaction is 50 Newtons. So that's 0.2 into 50. I hope everyone is clear why that N I'm taking as 50 and not 30, right? The total weight from the top. So How much is this? 0.25, 10 less than 20 seconds. So this is right and this is wrong. So 2 and 3 are slipping first. This you have to do every time. Luckily here it looks like 2 kg slipping first, but this is not true. I can mess up the values. If I had kept this 0.3 and this is 0.1, I could have made the 3 kg slip first. So it all depends on the values. So you can adjust them. So here this is clear. So 10 seconds may 2 kg slipping first. So 2 kg and 3 kg slip first. That means 3 and 5 will still go together. So for t greater than 10 seconds, two kg slips and 3 and 5 kg go together. I could have get a scenario like, where 3 kg slips and 2 and 3 go together. That also can be done. Same thing, like, different combination, but the story is the same. So draw the FBD of the 2 kg. This friction has become maximum, which is 2 newtons. So acceleration of 2 kg will be 1 meter per second square. Then take the 3 kg and 5 kg together. This friction has become maximum, which is 2 newtons. Now assume these two are going together. And let's see when it slips. Remember, previously when we did this, we got 20. This is actually wrong because you derived a 20 under the assumption 2 kg and 3 kg were not slipping. Let's see actually how much we will get. So take any one block. So what is the acceleration here? T minus 2 is equal to 8a. I think these values looked kind of same. They look kind of same as before only. 1 by 4. This is F1, this is F2. F2 has still not become maximum. F1 has become maximum. F2 minus 2 is equal to 3 into T by 8 minus 1 by 4. These calculations now, how much is this? 3T by 8 minus 3 by 4 plus 2. That will be plus 5 by 4. This must be less than equal to 0.2 into 50, 10 newtons. 3T by 8. 10 minus 5 by 4. 40 minus 35 by 4. 4s are to 35 to 70. 70 by 3. 70 by 3 is how much?
23.3.
23.33. Actually, the time is more. It actually took more time to slip. Am I right? Did I mess up the calculations anywhere?
No, sir, I got the same.
Same now. So we get F2 will be 3T by 8 plus 5 by 4. This should be less than equal to 0.2 into 50. So there, so we get T less than equal to 70 by 3. So the slipping actually starts at 70 by 3. So at this point, 3 and 5 kg slip. Yeah, tan theta ka values, so you can see. I think the thetas, they will remain same only, I guess. Here 1 by 10, that is 1 by 8, and the next thing will be, let's say 1 by 5, I guess. So for t greater than 70 by 3, they slip. This is tiring, right? Writing equations, slipping, moving. So I think one problem is fun. So many problems can't do anything. So this is F1 max, this is 2. This is F2 max 10, and this is the acceleration of 3 kg block. That's 8 by 3. Five kg block. F2 max, this is 10, and this is T, and this is acceleration. This will be T minus 10 by 5. The slope will be 1 by 5. You're done. So plot the graph. So all of them will go together till 10 seconds. Then the first slipping will occur at 10 seconds, and the next one will occur at 70 by 3. So all will go together till 10. Then your 2 kg becomes constant. Then your 3 kg becomes constant. And gone. This is your 5 kg. That will just keep going forever. Theta 1, theta 2, and theta 3. Tan theta 1, 1 by 10. I got from here, look at this, y is equal to mx, m ka place mein 1 by 10. Y is equal to mx plus c, m ka place mein 1 by 8. Y is equal to mx plus c, 1 by 5. Check. Clear with this? There, that's how you handle 3 block problems. Clear with that? With that, we're done with the chapter. So if you see the whole chapter, right, it looks same like NLM. There's not much of a difference. The only thing is we need to know how to find the directions, and we need to know how to find the magnitudes. Once you get that, put it in an FBD and solve. We saw different ways. That was the biggest headache in the thing. And the 2 block problems are one type of models there. So yeah, that's it. What more? You guys got used to doing that big things, no? Kinematics and all. Chapters will be small, right? Every chapter is not as big as a kinematics. Anyway, we did all these models. You'll be able to handle everything now. So do start solving. I'll send you a sheet also on this. So do finish your HCV. If you're doing HCV, I think there are around 34 questions or something. We can keep doing more and more problems, but with whatever I taught you, you'll be able to handle most of it. Everything will be just a variation of something. There. So next class when we catch up, we will continue from there. We are going to start with circular motion. So don't think friction got over. Friction will come again. Nothing is over. Kinematics, NLM, friction, everything will come. Once circular motion gets over, everything will come again in work power energy. So this will just keep happening. When I teach you the 15th chapter, everything will keep coming. Okay. So I think we will wrap up with that. We'll wrap up a little early anyways. I won't start the new chapter. So on Thursday when we catch up, we'll start off with circular motion. So do make sure to go through the entire notes. Even though it looks like with 22, we did multiple cases A, B, C, D and some problems. So do make sure to go through everything. And there's a test online on Thursday, so make sure to give it. So okay, that will wrap up for that. So any doubts in the class notes, any other doubts, please stay back and ask, or else you're free to leave. I'll see you on Thursday, same time. So take care, stay safe.